can read the power supply to give more voltage out. What's going on? Yes, the voltage was so high, the arcs, instead of jumping at the output, they were jumping across the resistor.
Hello, my name is Thomas Pingnam, and welcome to my engineering project video. Due to climate change awareness and ever-increased cost of living pressures, there has been a significant increase of residential solar installations on the energy grid. Government subsidy has been the main driver for this. We can see here that in the last 10 years, 3.36 million solar systems have been installed in residential houses. While the intent is good, solar generation has its flaws. Solar tends to generate most power in the middle of the day, when the grid doesn't need it, as consumer load is generally minimal due to most people not being in their homes and they may be at work or school. At this current stage across the country, there are only 180,000 battery systems currently installed, coupled with the solar system. This leaves 3.18 million solar systems without any battery storage system and approximately 29 gigawatts of generating capacity that needs to be managed. What most people don't realize is that our energy grid was never designed to account for this type of end user generation. All of this is having massive detrimental effects on our energy grid. We are seeing effects such as power stability, voltage rise, thermal limit exceedance, reverse power flow, and increased fault levels. This project is specifically looking at the effect of voltage rise on the grid. Have you or a friend recently installed a solar system without battery storage, monitored your energy bills over a few periods, and not noticed a real substantial difference? Well, excessive voltage rise in your area is probably the reason why. This project aims to create, refine, and successfully model the grid circuit behaviors of photovoltaic inverters programmed to Australian standard set points versus inverters with no power control. The model will show the effective response of photovoltaic inverters in maintaining low grid voltages to acceptable standards through the management of reactive and active power. We have three main objectives. 1. Raise awareness to the general public in hopes that education drives more installation of residential battery storage systems. 2. Effectively model the current problem using electrical engineering computer software PSCAD to obtain quantifiable data for this report. 3. Program an inverter to an Australian standard specification and model using PSCAD to show its effectiveness in maintaining grid voltage. Research. Extensive literature review was conducted on Australian grid standards, energy grid specifications, and the effects from high PV injection. 2. Build inverter model. A functional inverter model was sourced, control logic in-depth reviewed, modified, and implemented to suit our function. 3. Program inverter control. We had to code Australian standard power set points for active and reactive power. We had to also code radiance profile for generating control. 4. Build low voltage distribution grid. This included programming realistic values for transformer supplies, distribution lines, and residential loads. 5. Model circuit behavior. We aim to demonstrate higher radiance events with low consumer demand, replicating a typical midday event. Next, we will display the results from the project. The graph on the top is the results from a distribution system with no grid code control. The bottom screen is the results from the same distribution system, however with inverter control logic complying to Australian standards. The system undergoes 4 deloads occurring at 4, 5, 6, and 7 seconds. With the inverters with no control, we can see the voltage levels becoming dangerously high, exceeding 1.22 per unit, equating to 290 volts at the distribution grid. The bottom graph shows our inverters effectively controlling active and reactive power to maintain grid voltages to acceptable standards. This project demonstrates the current issues increased solar installations are causing to our energy grid. We reinforce the importance of our Australian grid codes and how compliance to them ensures our grid operates in a safe and stable manner. This project hopes to educate those unaware and to aid the implementation of solar battery systems. Further to this, it is clearly seen how effective controlling reactive power is in maintaining grid voltages, and this should be further investigated as we have many more opportunities for improvement and further applications in this area. Thank you.